In this video, we're going to discuss the inverse trig functions and how they help us find angle measures. To use the inverse trig functions, you're going to want your completed unit circle. From that unit circle, remember that cosine of an angle theta will give you the x-coordinate, and sine of theta will give you a y-coordinate. So for example, if I wanted to know all of the angles from 0 to 2 pi, that when we plug them in, cosine of that angle is negative square root of 3 over 2. Then what I'm looking for is the places where the x-coordinate is negative square root of 3 over 2. So that actually happens in two places. Here, x is negative square root of 3 over 2, and here x is negative square root of 3 over 2. The two values of theta that happens at is 5 pi over 6 and 7 pi over 6. If we want to know all the places where sine of theta equals 1/2, remember sine of theta is equivalent to the y-coordinate. So we want to know where is the y-coordinate 1/2. And this will actually happen in two places. Here y is 1/2. And here y is 1/2. So this happens when theta equals pi over 6 or 5 pi over 6. Notice how for all of these coordinates, you could pick any coordinate in the unit circle, you'll get a theta that will give you that value in two places. So we want to talk about how to limit that down to get us one specific angle. One of the ways we do that is by talking about arc cosine. This is simply just the inverse of cosine. Arc cosine is the same thing as cosine inverse. You may have seen that button or noticed that button on your graphing calculator. But what arc cosine of x does is it gives us the theta that corresponds to that x. It switches the inputs and outputs of the original cosine function. So in arc cosine, we're going to put in an x-coordinate or a ratio, and we're going to get out the angle that goes with it. But notice that we are only going to use from 0 to pi. We call that the principal root if we're talking about an arc cosine or if we're talking about a cosine function. So from 0 to pi, we're only using this region for arc cosine. So if I want to know arc cosine of negative square root of 2 over 2, this is going to give us a theta. We only look in the top region of the unit circle. So we're only going to use this value for theta. That would be 3 pi over 4. If I want to know where arc cosine of 1/2, what angle that is, here is 1/2 in the top part of the unit circle. Arc cosine of 1/2 equals theta, and in this case theta needs to be pi over 3. So if you're using arc cosine and you want the principal root, we're only looking at the top part of the unit circle. Arc sine will do the same thing. We're going to do arc sine of some y-coordinate and get out a theta. What's different is the principal root. It's negative pi over 2 to pi over 2. That is referring to this region. So this is where we're looking for arc sine. And notice these angles here, if you move to the right, we're counting these angles negatively. So if I want to find arc sine of 1/2, that's a y coordinate. I want the theta that goes with it, and we're only looking in this right region of the unit circle. Here is where y is 1/2. That's at positive pi over 6. Okay, since we're working with arc sine, let's swap this out. Let's make this arc sine negative square root of 2 over 2. So this is saying, where is the y coordinate? Negative square root of 2 over 2. And that would be right here. And traditionally we'd call that 7 pi over 4. But we're thinking about angles in this red region here as negative angles. So previously, this would be positive pi over 4. That means this amount going in the same direction. This is negative pi over 4. Anything in that red region, if we're talking about the principal root using arc sine, is going to be a negative angle. So let's look at the difference between the two. Let's use these to solve some equations. So I want to know cosine x equals square root of 3 over 2 from 0 to 2 pi. If we divide by 2, cosine of x equals square root of 3 over 2. So we want all of the values from 0 to 2 pi that if we plug them in for x, it give us square root of 3 over 2. That happens here. And it also happens here. So x could be pi over 6 or 11 pi over 6. Now we're asked to solve an equation, but we're going to use the principal root, and we're doing so for sine. If we're talking about sine, we are only going to use this region of the unit circle, and the things that are to the right of 0 degrees, we're going to count as negative angles. So first, let's solve this for sine of theta. Minus square root of 2 from each side. 2 sine of theta equals negative square root of 2. And we divide by 2. Sine of theta equals negative square root of 2 over 2. To solve for theta, theta is given with the arc sine. We want to know what is arc sine of negative square root of 2 over 2. We want the principal root. As we discussed previously, here is the y coordinate negative square root of 2 over 2. And we would say that's 7 pi over 4, except we want to go, think of this amount as negatively, moving negatively. So here theta would be negative pi over 4.